Most of you have heard that steam at 100 degrees Celsius causes more severe burns than boiling water at 100 degrees Celsius. Why is that? In order to understand, we need to understand the energetics behind the process. Let's dive in. We generally tend to associate heat with rise in temperature. Is this always correct? Let's investigate. Take two jars. One containing boiling water and the other ice. Measure the temperature of the two contents under standard atmospheric pressure. While it reads 100 degrees Celsius in the case of boiling water, it is 0 degrees Celsius for ice. Now let's supply heat energy to both of them. You can notice that there is no change in the temperature of either the boiling water or ice even when they are being supplied with heat energy. The temperature is constant at 100 degrees Celsius and 0 degrees Celsius respectively. Why? How do you account for the supplied heat energy? Has it gone latent, which in Latin means lying hidden? It will be interesting to know that this phenomenon is the result of specific latent heat of substances. Let us understand the concept. To begin with, take m kilograms of ice at minus 20 degrees Celsius under standard atmospheric pressure. In its solid state, the molecules of water are bound together by strong intermolecular attractive forces and vibrate slowly about their mean positions. However, on supplying heat energy, the molecules start to vibrate vigorously and the temperature gradually rises up to 0 degrees Celsius. At this temperature, the ice starts to melt, and what's surprising is that even though heat energy is being supplied continuously, the temperature remains constant. Why does it happen? This happens because during this time, the supplied heat energy is absorbed by the molecules and they overcome the intermolecular force of attraction. In other words, molecular bonds break and molecules move apart, freed from their rigid structure. Ice transforms its phase from solid to liquid, with the temperature remaining constant until the entire mass melts into liquid water at 0 degrees Celsius. The amount of heat energy required to transform a given quantity of ice into water with its temperature remaining constant is known as heat of fusion. For any given substance, it is represented by QF and is given by QF is equal to m times LF, where m is the mass of the solid substance and LF is the specific latent heat of fusion of the substance. Specific latent heat of fusion of a substance is defined as the amount of heat energy required per unit mass to transform its phase from solid to liquid or vice versa at constant temperature. It is an inherent characteristic of a substance and its SI unit is joules per kilogram. For ice, LF is equal to 333 kilojoules per kilogram, which implies that 333 kilojoules of energy is absorbed to convert 1 kilogram of ice to water. Similarly, 333 kilojoules of energy will be released to convert 1 kilogram of water into ice. On continuing the supply of heat energy, a further increase in the vibration of water molecules is observed and the temperature gradually rises up to 100 degrees Celsius. At this temperature, water starts to boil and the temperature again becomes constant despite heat energy being supplied to it. During this time, the heat energy absorbed by the water molecules is enough to overcome the intermolecular force of attraction and they move farther apart. Hence, water further transforms its phase from liquid to vapor. Note that during this period, the temperature remains constant till the entire water has transformed into water vapor at 100 degrees Celsius. The amount of heat energy required to transform water into vapor while the temperature remains constant is known as the heat of vaporization. For any given substance, it is represented by QV and is given by QV is equal to m times LV, where m is the mass of the liquid and LV is called the specific latent heat of vaporization of the liquid. Specific latent heat of vaporization of a substance is the amount of heat energy required per unit mass to transform its phase from liquid to vapor or vice versa at constant temperature. It is an inherent characteristic of a substance and its SI unit is joules per kilogram. LV for water is 2256 kilojoules per kilogram, which means that this amount of heat is absorbed to transform 1 kilogram of water into water vapor. It should be noted that the heat energy is absorbed to transform ice to water vapor, while heat energy is released to convert water vapor to ice. Specific latent heat for various substances is different, as shown in the table. Water has a large value of specific latent heat of fusion and vaporization. Hence, it is useful for many purposes. To summarize, specific latent heat of fusion of a substance is defined as the amount of heat energy required per unit mass to transform its phase from solid to liquid or vice versa at constant temperature. Specific latent heat of vaporization of a substance is the amount of heat energy required per unit mass to transform its phase from liquid to vapor or vice versa at constant temperature. Values of LF and LV are characteristic of a substance and their SI unit is joules per kilogram. Have you ever wondered, why do we cool down after we sweat and sit under a fan? We know it expedites the process of sweat evaporation. But what is its relation with cooling effect? Well, you can apply the principle of latent heat